Okay, so for your intro to triangles notes here, this will be intro to triangles and then trig as well. You have, for the first problem, we have triangle ABC is inscribed inside a square with a side length of 20 centimeters. Find the area of the triangle. So I've already drawn this here, except I'm not very good at drawing. So when you all have to draw, I'm not going to judge your drawing because this line I didn't actually hit it down here. So this should be the side of the triangle, and I just didn't start over. You have, it's triangle ABC here, so here's ABC. It's inscribed in this square with a side length of 20. So, of course, for a square, that means all sides are 20. And then you want to find the area of that triangle. So if you use the area formula for a triangle, you have the area is equal to 1/2 the base times the height. And so we will plug those numbers in. So we have A is equal to 1/2 times the base. The base of your triangle is here. So the base actually is also the side of the square, which we know is 20. So 1/2 times 20. And then times the height. So the height of the triangle is if you drop I can't talk and do that at the same time. Drop a vertical line down perpendicular to the base here. This would be our height, and it forms a right angle because it's perpendicular. That would be the height of the triangle. So we don't actually have the number there, but since it's inscribed in a square, the square is even on all sides, so this height also has to be 20 because it's from here to here, which is 20, and so this also has to be 20. So we have 1/2 base, which we know is 20, and height also has to be 20. So 1/2 times 20, if you want to do it in steps, or you can do it all at once. You've got 10 times 20, which is 200 centimeters squared. So for that one, if it's inscribed in a square, all we have to do is you use the base, which is the same thing as the side length of the square, and then draw your height in. And again, that's the same. It's the same as the side length of the square because it's a same as this side here. So that's the first problem. For number 2, we have an isosceles triangle. Forgot an S. Isosceles triangle has angle A that is 30 degrees greater than base angle B. Find all the angles of the triangle. So for an isosceles triangle, the rules are that your base angles have to be equal. So these are my base angles. Base angles don't necessarily, they could be like this way too, but since it's base, we think bottom. So these are my base angles. So my base angle is B, and they have to be the same. So this is B, and therefore that's also B. The other thing for isosceles triangles is that these two sides would have to be equal. So for isosceles triangles, you have the two base angles and the two sides are equal. And then this would be my angle A. So it tells us that angle A is 30 degrees greater than base angle B. So angle A is 30 degrees greater than, which is add, so B plus 30. So if you want to say this is equal to B plus 30. Then we know also that the angles of a triangle have to add up to 180 degrees. So we have a B angle and another B angle because they have to be equal. So both angles here are equal. A is in terms of B because it's B plus 30. Based off what it said, we know the three angles have to add up to 180. So therefore we can do angle A, and I'll write it out this way, angle A plus this angle B plus our other angle B has to equal 180 degrees. We know A is B plus 30. So we have B plus 30 plus B is equal to 180. So that gives us 1, 2, 3 B's. Plus 30 is equal to 180. Solve for b. If we subtract 30, we get 3b is equal to 150. So divide by 3. That means b is 3 into 150 is 50 degrees. So our base angles are both 50 degrees. And then our angle A is 50 plus 30. Write it down here. Can't write that small. So A is B, which is 50 plus 30, which gives us 80 degrees. So all angles of the triangle are 50, 50, and 80. So for the last problem, for just an intro to triangles, we have find the area of an equilateral triangle that has sides equal to 10 centimeters. So for an equilateral triangle, we have, here's this equilateral triangle. It's supposed to be that all angles and all sides are equal. So the sides are equal to 10 centimeters. So this is 10, this is 10, and this is 10 centimeters. For the area of a triangle, again, we're using 1/2 base times height. So we know one of these, if we have area is equal to 1/2 times our base is 10, any side is 10 really, so we know 10 is the base times our height, which is the question. So again, if you draw this vertical perpendicular, this is H. So it's not inscribed in a square this time, so we can't use the fact that it's the same as the side length of the square. It's just there. So you do have this right triangle here that it forms though. Because this is an equilateral triangle, if you draw this vertical perpendicular, this is going to split the base in half. So this point here, it should be, doesn't look like it on my picture, but it should be equidistant this side and this side, because you're talking about an equilateral triangle. So if you go from the top down, then it'll split it in half. So this will be 5 and this will also be 5. So I'm going to call this M, just to write a few notes here. So M is the midpoint of, and we can label our triangle here so we can use some letters A, B, C. So M is the midpoint of AC, which means if you have a right triangle and you know two sides, you know this side here and the hypotenuse, so you know a leg and a hypotenuse, you're looking for this leg, you can use Pythagorean theorem. So we're going to find H using Pythagorean theorem. So everybody knows the Pythagorean theorem says a squared plus b squared is equal to c squared. If you have a triangle that looks like this, here's your right triangle, c is the hypotenuse, a or b doesn't really matter. I'll just do it that way. So the leg squared plus the other leg squared has to equal the hypotenuse squared. So for us, we have 5 squared plus, here's our h, so h squared has to equal our hypotenuse, which is 10 squared. So we have 25 is 5 squared plus h squared is equal to 10 squared is 100. Subtract 25, we get h squared is equal to 100 minus 25, which is 75. So take the square root of both sides, you get the square root of 75. Usually you do plus or minus, but we're talking about lengths. So usually when you take square root, you always do plus or minus. But if you're talking about lengths, lengths can't be negative, so you only can use the positive, so you don't necessarily have to worry about the negative side. So h is the square root of 75. You can do it as a decimal if you want to. I usually just leave it as that to key it in on the calculator. So up here was our question mark for h. That's what we were looking for, so we have that now. So our area is 1/2 times our base, which was 10, times h, which we found to be square root of 75. If you type that on the calculator, you get 43.3, I think is what I've got over there. So it should be 43.3 centimeters squared. Let me double check that. I think it's a 3. Okay, so we're also going to do an intro to trig here. So some people hear trig and they get scared. But we're not going to do anything like real major, just a few basic things. So for trig, we deal with right triangles, which we just touched on with the Pythagorean theorem. So we have sine, cosine, and tangent. That's what we're going to focus on. We're not going to talk about secant or cosecant or cotangent or anything like that. So sine, cosine, and tangent. So here's your right triangle. You've got A, B, and C are the sides. C is the hypotenuse here. This angle's theta, or you can also talk about this angle, but for this up here, I just have this angle here is theta. So you've got your right angle. Your hypotenuse is always opposite the right angle. So for sine, your sine of theta is always your opposite side. So here's our theta. If you go opposite to theta, you get to B over the hypotenuse. So this is always opposite over hypotenuse. For the cosine theta, it's always adjacent. So what's adjacent to theta on the same side here is A over the hypotenuse, which is C. So this is always adjacent over hypotenuse. And then your last one is tangent. The tangent of theta is always opposite. So if you go opposite theta, you're at B. So it's opposite over adjacent. So next to theta is adjacent. Now there's several ways to remember that, because you have to know it goes sine, cosine, tangent. Most people know that because that's the order it is on the calculator. So if you forget, you can look at the calculator and you know which way it goes. There's also different ways to remember this. I learned orange for opposite, horses for hypotenuse always have orange ankles. So opposite hypotenuse, adjacent hypotenuse, opposite adjacent. So I learned it that way. There's others, and I can't think of one right now for some reason. It's left me, probably because I'm talking about it. But there's other ones. I don't think this one's a very common one, but that's what my geometry teacher did in high school, and that's how I always remembered it. So however you want to remember that, and you can share on the forum if you have some other clever ways to do that. So for your examples here, we want to find x. So for this first one, you've got this right triangle. Side here is 3, this angle is 20 degrees, and x is down here. So in this case, we don't know the hypotenuse, and your angle's here. It doesn't matter, like I said up here, it doesn't matter what angle, you still just look at opposite, adjacent, and then hypotenuse. So if you look here at 20 degrees, you know if you go opposite that, you have x. So the opposite side is x, and then you also have adjacent, which is 3. So if you look up here at which ones deal with opposite and adjacent, that would be tangent. So we would have the tangent of 20 degrees is equal to our opposite over adjacent, so we would do x over 3. Solve for x, multiply both sides by 3. I'm going to write x on this side instead. We get x is equal to 3 times the tangent of 20 degrees. You can do that on your calculator. Make sure it's in degree mode, you get 1.09. And these, I think I usually say round to 2 decimals, I believe. So x is 1.09. For the second one here, we have this angle is 40 degrees. This is your right angle. This side is 6. The hypotenuse is x. So for this one, we know the hypotenuse is x. And if you look at your angle, this is the adjacent. If you go opposite, you don't have anything, so you don't know that. So you have the adjacent is 6. So if you go up here and look which one deals with adjacent and hypotenuse, that's here at cosine. So we would have the cosine of 40 degrees is equal to adjacent, which we said was 6, over the hypotenuse of x. Solve, multiply both sides by x, so we would have x cosine of 40 is equal to 6. Divide both sides by cosine of 40, we get 6 divided by cosine of 40. Oops, forgot my s. Which is equal to 7.83. So x, the hypotenuse on that one is 7.83. And for the last one here, we have this side is 15, the hypotenuse is 40, and you want to find x and y. So you need to decide which one do you find first. Do you find x first or do you find y first? It doesn't really matter. For x, you have 15 is the adjacent side, hypotenuse is 40. For y, you have opposite and was 15 and hypotenuse is 40. So you can pick whichever one you want to do. We've used tangent, we've used cosine. So since we haven't used sine yet, I'm going to find y first. So to find y, you have the opposite side is 15 and the hypotenuse is 40. So we would have the sine of y is equal to, because if you go back up here, hypotenuse and opposite and hypotenuse is sine, so sine of y is equal to opposite over hypotenuse, so it's equal to 15 over 40. And you can't solve these for trig functions. You can't just divide by sine. That doesn't work. You have to do the inverse. So you should remember seeing where you do sine inverse of 15 over 40. That's essentially the equivalent of dividing by sine, if you want to think about it that way, I suppose. But you can't just say divide by sine, because you got to take the sine of something, so you can't just get rid of the sine like you normally can, so you have to do the inverse. So you can also do that on the calculator. If you do sine inverse of 15 over 40, should be like second sine, I think. I don't have a calculator here staring at me right now to look, but if you can't find it, let me know. So 22.02, which I'm just going to say 0.02 is not worth worrying about, so 22 degrees is close enough. So we know y is 22, which means what's x? X, all the angles of a triangle have to add up to 180. So you've already got 90 here and you've got 22. So for x, we have 180 minus 90 minus 22, or 22.02 if that bothers you, but anyways, it's close enough. So we would get x is 68 degrees. And you could find x first. You could find x using cosine, because you would have adjacent 15 over 40. So you would have x is, or cosine x is equal to 15 over 40. So you do inverse cosine of 15 over 40, which will be close to 68, and then subtract 180 minus 90 minus 68 to get 22. So whichever way you want to do it, I just want to do one with sine. So this is just the introduction to triangles and trig. So for you don't actually have homework on this yet, because it's just a practice sheet. So you'll be able to practice. It's not for a grade. Your actual homework for a grade will be the next week.